Hi, and welcome to ImagingNation, a podcast brought to you by BMEII, the Biomedical Engineering and Imaging Institute here at the Icahn School of Medicine at Mount Sinai in New York City. My name is Jazz Munitz, and today I have the distinct privilege of getting to speak with three incredibly brilliant and people who have really been at the forefront of this fight in COVID, both from a research perspective and from a front lines perspective. So today we're going to be speaking a lot about AI, radiology, and how it overlaps specifically in the context of COVID, but also beyond and looking towards the future of radiology as a field and the interplay between people and machines in this context. So I'd first like to introduce Mike Chung. Mike Chung is an assistant professor of radiology specializing in cardiothoracic imaging here at Mount Sinai. So hey, Dr. Chung, nice to meet you. Thanks for coming.
Hi, thanks for having me.
Absolutely, yeah. And next up, we also have Dr. Adam Bernheim, who is an assistant professor of radiology as well, also specializing in cardiothoracic imaging, and also another incredible team member here at the Icahn School of Medicine. Hey.
Hi, thanks for having me. Pleasure to be here as well.
Absolutely, thanks for coming. And next up, we have Dr. Young, who is an assistant professor of radiology as well, here in the Biomedical Engineering and Imaging Institute at BMEII. So hey, how you doing? Thanks for coming.
Hi, thank you for having me here.
Absolutely. So let's jump right in. So what we're going to be discussing a lot today, and maybe a good jumping off point, is Young, your research throughout this time of COVID, specifically dealing with utilizing new AI algorithms that you designed in order to help work as a complementary diagnostic tool and in improving a complementary diagnostic tool in the fight against COVID and in trying to get accurate diagnoses of patients using CT radiology and a ton of else. So maybe in your own words, could you just give us a run through how did this begin? What are the impacts? Let's jump right in.
Okay, this is kind of a long story, but we can make it short. So as we know, the COVID actually starting early this year. First as in China, and at that time, because I'm a Chinese, so we got a lot of news from the media and also TVs. Then that spread very fast, and also a lot of cities locked down for the reason. And then luckily, because we are doing imaging, so luckily we have some collaborators in China. They in their hospital they scan some COVID patients using CT, just CT, high-resolution CTs. And then we just think about, because we are doing imaging, how about we first analyze the data? So that's why we do some research agreement to port data. And then we have Michael and Adam here in our radiology to read images. Actually, they too published two important papers. And then the first paper actually is describe the features of the COVID-19 patient from an imaging point of view in the CT images. Maybe Michael can give more detail in the later. And the second paper Adam published, leading the paper is to derive the time series, the causes of relationship with the severity of the COVID patient. And then we found, so because the reading image is not that simple, and then you need a specialist, to read images and to interpret images and even do the report. So at that time, only China has very a lot of cases. We don't anticipate that we'll spread out the whole world at that moment. And then we just after we do this paper, it's just like U.S. and they also started to have COVID patients, and all the world has started to have COVID patients. At that moment, we are thinking about because a lot of countries or like the hospital might not have the expertise to read images. So how about we use the machine or computer to learn some features from the images and then transfer, the knowledge from radiologist to computer, which we call AI system. And then that might help a lot of, either regions where lacks of the expertise of reading images. And meanwhile, when we find that the time series with the severity and also the COVID patient, we found in early stage of the patient, COVID patient, a lot of people have no symptom or no imaging features. So only using imaging might not be a very wise choice because you might cause some wrong diagnosis. That's why we also try to incorporate some clinical information, including some typical symptoms, blood work, and then exposed history, and then jointing it to estimate or diagnose the COVID status. Then we come up with this idea, and then luckily we are here, including the student Xuan Mei here. She's fantastic to getting all the data together and also do some modeling on the both imaging and the clinical information part. And then we just when we have the paper, we did the project very fast, like within several weeks, and then we wrote the paper, and then just say maybe we can submit to Nature levels, and then we just submit to that, and then after 2 rounds of revision, we got the paper published.
That's fantastic. And it makes sense why it went through so quickly. This is a really extremely pressing issue, and especially you guys got in right at the floor level, right as things were taking off, and really, created something that could make some real change, not only here, but, across the world. I really like that you brought up the point about access and places where, because we're very fortunate here at Mount Sinai to have the incredible radiologists who I'll toss it over to now, but it's not always so fortunate everywhere. So you're right, this is a global issue, and it expands far out of just the main metropolitan regions. So it's fantastic that you had the foresight to be designing something to help everyone. So would either Mike or Adam, would you guys like to hop in and maybe discuss how you see this coming into play, or just your experience being on the front lines here? What's the experience of a radiologist during this?
Yeah, I'll just add that I'll echo everything that Yan said, and I think we at Sinai, we're really blessed to have this opportunity to collaborate with people around the world, and specifically people in China for this pandemic. I guess in the early chapters or the early kind of stage of this pandemic, what was most pressing and what was most important to a lot of clinicians and radiologists was the early diagnosis, because the blood tests or the swabs, the PCRs, they weren't as accurate or as readily available as they are right now, just worldwide. So obviously, we thought that imaging would play an important role in kind of the clinical workup for suspected patients. And I think just reflecting back, it was an amazing experience to be able to collaborate with our colleagues in China and to really also put Mount Sinai on the map when it comes to COVID research and COVID care. I think it's just amazing that we were able to even write up these manuscripts regarding AI, and just because it is a bigger picture type of thing where it's not just the New York City population, but the whole world is going through this. It was great that Sinai was able to really cement themselves in this way.
Absolutely. And Adam, what's your experience been?
I very much agree with both Yang and Mike. I certainly would echo that it's been a privilege to have been in a position where we're able to make a positive contribution to our field. I think that radiology, we understood immediately that radiology is foundational for diagnosis of patients with suspected COVID-19. And we were just in a very fortunate position because of great colleagues and good connections that we had with some of the Chinese hospitals through Yang and others, that we were able to have access to a lot of scans early on and be able to put out some data that I think is helpful. So it was just a privilege to work with good people on a good project that hopefully has made a positive contribution to this pandemic.
Absolutely. And there's also really something to be said about the way in which the scientific field has interacted in this collaborative way. I mean, as we were doing research and COVID research in our lab and here at Sinai, it's not so much just about the publication, it's not about career advancement, it's about getting data as quickly as possible, or whether it just be in the idea of raw images and making those out there so that people like Young and like you guys could train AI algorithms in order to start using it as a diagnostic tool. It really does speak to how important it is to make sure that everything that we're creating in science is open and accessible for everyone to do, obviously all within HIPAA regulations, of course, that's the massive important part, but in order to see where this kind of data can take us. And it really seems that here it's created an incredible tool. So I'm also a little bit curious, can this... so maybe let's walk us through. You're integrating clinical presentations. You're integrating a maybe SARS-CoV test, SARS-CoV-2 PCR test, an RT-qPCR test, is that have a predictive measure? Maybe discrepancies between those. Would that also implicate whether a radiology test is necessary for a specific patient?
So I can first, chip in to say something. So first, our AI algorithm, we didn't incorporate the SARS-CoV, to test. The reason is, so usually, the motivation for us to do this research using CT or check the imaging and clinical information is just as Michael and Adam mentioned. In the very beginning of the pandemic, there's a shortage of the tested, and also the timing to process that is incredibly long. Sometimes several days, or right now they are maybe faster, up to several hours or even shorter. But at the very beginning, it's very long, so like multiple days maybe.
Right.
And then meanwhile, so a lot the most important reason is a false negative rate, which means the SARS the test, if the result is a negative, that doesn't mean real negative. So we see a lot of cases with a negative test, but some positive in the chest CT scans. If they do the multiple tests, maybe they'll be positive. So if a positive, we are more confident. Okay, the patient will have the COVID. But if a negative, it's hard to say. So that's why in a lot of countries, their guidelines is to do multiple series testing if negative to make sure to all fully rule out the COVID status. And then it's interesting, like in the CT images in the early stage, I just mentioned, there's some, even you don't, so the test is negative, so there's still some chance to see some, image features of the typical features that like ground, GGO, which, both the radiology can give more details about that because we are more technical person to use their knowledge to transport that. But I want to say the chest CT images might have some merit for early diagnosis. Although this is not widely used in US, but it's already widely used in like China, some European countries, even for screening purpose. Some reason to tell you, I'm not totally know the reason why US here is not using that as a screening. Maybe some radiation dose or other reasons. But I think the merit for the CT images or like or chest X-ray images are very very high compared to only using like the test kit.
Gotcha. Adam, could you please just to kind of explain and maybe break down what a CT is, just in the scope of this and in the scope of a chest X-ray? I think a lot of patients might hear that, but what does it truly mean? What are we looking for when you're actually doing one of these radiology scans?
A CT scan is a very powerful tool to be able to get an inside look at a patient's anatomy at a three-dimensional level. We can image a patient, for example, in their chest and have hundreds of sequential scans slice by slice through the patient, which allows us a very detailed look at their anatomy and therefore pathology affecting the chest. One of the tremendous benefits of CT is that because it gives such an inside perspective, much more so than a standard radiograph, we're able to see relationships with anatomic structures well, and we can rule in and rule out many diseases very, very effectively. So CT in general is an incredibly powerful tool in medicine, and it has applications that span the gamut of pathology. But in patients with coronavirus infection, we do find that many patients have typical abnormalities that can be identified on CT. And one of the things that we found in our work, as well as the work of many other good groups throughout the world, is that sometimes the pattern of disease in COVID-19 has a pretty characteristic appearance on the CT images, which is very helpful for us, not only in suggesting the diagnosis, but in distinguishing it from other possible etiologies. And in addition, we're able to correlate some of the findings with disease time course and progression of disease and complications that may develop. So all of these are very valuable pieces of information to know for working up any given patient. And really CT is at the heart of ruling in and ruling out certain findings and complications and progression of disease.
It's fantastic. Thank you for that explanation. That was super clear and concise. I'd like to ask a little bit more about some of these pathologies that are being seen and some of the findings of the radiology. I've read a few papers, and I know that people are describing these things called ground glass opacities or these crazy paving patterns. And I know that things have, that was from papers from a few months ago, so maybe things have progressed. What now when you guys are looking at radiology scans, chest x-rays of COVID patients, what are you really looking for now? What are the specific things you see?
Sure. So it's funny, people ask me about ground glass opacities all the time. What it really means is that on a normal CT, the lung, because it contains mostly air, should be black because air is black on the CT scan. But when the lung starts to become diseased and be filled with other things other than air, such as fluid, cells, pus, or debris, it starts to turn gray and even white. And what we notice is that in some patients with COVID-19, specifically early on in disease time course, they often have these gray areas in the lung, and they're termed ground glass because they're just bright enough that you can see them, but they're not so bright that they completely obscure the architecture and anatomy of the lung. So imagine, for example, a shower door or a glass door, which is lucent. You can see through it, but it's just cloudy enough. It's just hazy enough. You cannot make out fine detail behind it. Like, for example, behind a glass door has a sort of ground glass appearance. So that's what really the analog and the correlate is on the CT scan. When we see these opacities, we certainly see them, but we are still able to see through them and to still see the normal anatomy and vessels and airways in the lung. But they're a bit obscured and a bit hazy.
Gotcha. That's fantastic. Thank you. I'm so glad now I understand that. And everyone listening does as well. Gotcha. So in this, are these ground glass opacities and these crazy paving patterns, are these present throughout all COVID positive patients when you do a chest x-ray? Because it seems that some of Jung's research says that might not be the case.
There are false negatives. The ground glass opacities are seen really best on CT. There are false negatives. So one of the things that several researchers have discovered is that while ground glass opacities are a hallmark of COVID-19 on CT, they're not present in every single case, particularly very early in infection. So if the patient has a CT scan very quickly after symptom onset, they may not have the opacities yet. So while they are characteristic and typical and suggestive when seen in a certain shape and certain location in the lung, they're not present in every single case. So the absence of seeing them does not confidently allow 100% ruling out of the diagnosis.
And it also can be quite tough, I would assume as well, because I'm sure that there's a lot of overlap between COVID-19 lungs and different coronavirus lung presentations of lung infection. So how have you guys learned to delineate between these things? Or are you really relying back on RT-PCR and these other tools that we have to diagnose COVID in a non-radiological setting?
Well, oftentimes we won't have that RT-PCR. I guess during the pandemic, we wouldn't have the RT-PCR information right at hand because it was happening concurrently with the scan itself. But your question was how to differentiate it between COVID and other infections, I guess? Was that your question?
Exactly, right. Because from an outside perspective, it seems, it can seem like all inflammation in the lungs would be, a very similar inflammation in the lungs no matter what's going on. So for all of us, can you kind of maybe speak a little bit more to, how can you tell? How can you tell?
So you can't 100% tell, obviously, but it really depends on the setting in which you're working. So during the month of March, April, May, in New York City, specifically when it was the epicenter of COVID in the world, those kind of characteristic findings would make us think of COVID-19 as the initial diagnosis. However, if we weren't in New York and we were, say, in the Midwest or on the West Coast at that time, given that it might have been the tail end of the flu season, we might have also included influenza on our differential if you saw something like that in the lungs that Adam was describing.
Right. That makes sense. Isn't there the old trope in medicine about if you're in Wyoming and you see something that looks like a horse, it's probably a horse and not a zebra. Yeah. Very cool. Very cool. So, Jung, so I also think it's really incredible that you focused in on CT because, again, the CT is such a characteristic modality. It's such a baseline clinical tool that so many hospitals seem to have. Did that go in and factor in a little bit about using CT versus MRI versus other imaging principles? Obviously, there are benefits to CT, but can you break down a little bit what that is?
So yes, so actually, just all Michael and Ned mentioned, the chest CT image is kind of standard clinical care, but not for screening in some hospitals. The reason is the chest CT have very high spatial resolution, and then you have multiple slices, which means you can capture the anatomy detail in very detailed levels, which will be very good for the image analysis. You can imagine if the better detail you have, the easier you can grab some information from those. And then this is why we also using that for the AI, because this is kind of like a simple question first, compared to chest array, which is only one image, contact all from all directions together. So the chest CT, especially high resolution chest CT, have very rich information, as they mentioned. And meanwhile, I just also want to mention, like for MRI or other imaging modality, they might not be very, based on the imaging, modality characteristics, in some imaging speed or other reasons, so they are not, good for COVID, screening purpose, especially for MRI. You can imagine, I'm doing MRI a lot. So MRI, is very sensitive to some air tissue, interface. You can imagine lung, it's all airs,
Right.
There will have a lot of imaging artifacts unless you use very specialized images. And then the scanning time is very long compared to chest CT. Like boom, chest CT, maybe like the whole breath hold 10 seconds, you can do that. But for MRI, you maybe need like minutes, even 10 minutes to do that. So, which is not that easy. And then, especially for this special disease. And also, we will try to make it as fast as possible, and then to reduce the infection rate for the when you do a scan. So that's a major reason why we use CT. And majority reason just mentioned, like the rich for imaging features we can do, and then for other reasons, just I mentioned specific for this the COVID disease.
Right, yeah, and that seems to make sense, as well as, if it's a much shorter scan, these are patients who are having some breathing symptoms. They're having cardiopulmonary issues, so to have to hold breath for a longer time than necessary, that I'm sure can be a bigger challenge than it might typically if you're just going swimming or something like that. I understand. So I would love if you could break down a little bit what goes into building an AI algorithm, what goes into training a network like this, because how does this really work? It's AI and ML and machine learning is such a huge buzzword, but I feel like we hear it tossed around more than we hear it truly explained. Exactly.
So the first maybe term you think about AI, maybe we call it black box. You don't know what they are doing for those. So similar, like
really cool. Just the black box concept is you train something, you build an algorithm, and you get the output and it's correct, but you're not sure how that algorithm actually created the correct answer. You have the answers, but you're not sure what questions they were asking, and that's how we learn from them. So yeah, sorry.
So that's why when we designed this one, we actually based on try to mimic how they do, like the radiologists to read images and then to design a system. So for example, when we have first chest CT images, they have multiple slices. So you can do like pure 3D training. We don't care what kind of image inside, just treat the whole image as input to the system. So actually we do a two steps. Firstly, we try to do some slide selection to have the major features, like just like the radiology read images. So they quickly go through all images. They identify some key slices and then look detail into that. We do the similar stuff. So we first do the slide selection, and then have the major features. And then once we have major features, and then we move that using that slices, pre-selected slices for next diagnosis, network. And then for diagnosis network, the input is selected slices, and output is like RT-PCR confirmed, yes or no. And then for this, we are using this is kind of more a backup box now, using the pre-trained model. So you can imagine, so the pure chest CT images, even we have thousands of cases, that's still very small compared to nature images. So that's why we use some nature images, like cats and dogs, some pre-trained networks. Like some of them we can call there are tons of some that work to grab different level of features. So we kind of use some transfer learning. So learning, so using some pre-trained model from nature images, and then we additionally learn the image features from the chest CT image from COVID data, COVID patient or non-COVID patient, and then combine them together to do some prediction. So it's not that pure. We just using the data we have. Like for example, if we have 1,000 cases, we didn't only grab a feature from this 1,000 cases. We also borrow some experience from some nature images, like edges, or shape, etc. So you can, enhance your power of your the training part. And meanwhile, when we do design the system for AI, you need to do design very carefully about you need to separate data set into testing set, training set, and then validation set, and then testing set. Training set, which means you use the data, part of data for the 1,000 cases, using 60%, 600 cases as a training. You gain and then train the model and features. And then meanwhile, after you do a train, we also using small portion of data to validate your result, which means the network still see the validation test set to, further, optimize or improve your performance. After you have the whole model, we are using the pure called testing set, which I have never seen by the AI, and to predict the performance to see how comparable that is compared to the radiologist's performance. So this is a general story about those.
Gotcha. That makes sense. Thank you for explaining. So that must have been a really exciting moment, though, when you first put that the unvalidated data back in and saw that it created some of the correct outputs. What was that like for you?
Because to tell you, I'm not directly doing that. Okay. So, but when the first train, shared our students to share the news or the result to me, we are excited because to tell you that even at the very first round of training, we get a reasonable performance. Definitely not as good as we reported in the paper, so we optimize that. But at the very beginning, the initial result is already excited. Interesting. Okay, by doing that, we can learn some features from the radiologists, and then that's cool. And then maybe you can help the work. The kind of I'm the hero of the work kind of. But anyway, it's kind of a teasing for those. Just kind of like we want to. It's kind of all kind of stuff. When we have some exciting results, we are always very joyful about those. And then kind of our hard work is paying back. Kind of that feeling. Yeah.
Right. Exactly. And so now to kind of switch gears a little bit of perspectives, Adam and Mike, where do you guys sit on AI's integration into radiology? What have you guys seen in your day-to-day and your function, and where do you perceive it as going?
It's a really good question, and I think I would just offer an introductory, prefatory comment to AI in general for myself. I think that my own position and my own thoughts have evolved in the last maybe 3 to 5 years. I think initially, as a radiologist, when AI first started to emerge as something that people were talking about a lot in the conferences, in the literature, in the journals, I was definitely very skeptical. I'm reminded by the hype cycle. Many people may know of the Gartner hype cycle, where a new innovation is often felt to be very promising, and there's almost a certain sense of unrealistic expectations. And I think that there are many applications of innovation that fit the hype cycle that we see in our world, whether it's 3D printing or autonomous driving. I think there are many applications, and I think that AI in some ways maybe is something that fits that paradigm in some way. But I think in the last couple of years, I've started to recognize that AI truly is going to be foundational for the future of radiology and will have an enormous impact in our field and in all of medicine. I think that it's going to be a process, and I think that we're only in the most early innings. I think we're really just starting, and I think it's going to have a long way to go and will require patience, and there will be many obstacles along the way. So I think it's going to be a journey with a long time course. But I really do think that the future belongs to those who are in the driver's seat of AI. So that's why I think it's wonderful to be here at Mount Sinai. We have wonderful colleagues and wonderful people working at BMEII and others who are forging that future ahead. So I think in practice, in day-to-day clinical practice, for me as a radiologist, I don't think my life is changing that dramatically with AI tomorrow. But I do think longer term, over the course of the future, it really will be transformative.
Incredible. Mike, what do you think?
Yes, I also want to add several comments.
Yeah.
So
absolutely.
Yeah, Alan. So that's kind of like some people always say, okay, when AI come in, it's whether we will replace the radiologist.
Right, that's always a discussion.
Answer actually is no, because always we all just say the AI is kind of we are providing an additional tool for the radiologists to aid them to more efficient to read images or like make a quick diagnosis or decisions. So we kind of like we are the friends, like AI is the friends of the radiologists, kind of provide them the help and then make their life easier and then not try to replace it. Just
AI can do a bit of the grunt work.
I agree completely. I think it will be a tremendous complementary tool to help radiologists. We're so overwhelmed and nationally in terms of our volume, and I think AI will be eventually very, very helpful for us. I agree with that completely.
Yeah, one of the ways that I've really seen it become very useful, I work on the preclinical imaging side, and a lot of the AI segmentation tools that have started to be released that you can add as plugins to, the viewers. I use Osirix, have really been incredible. It doesn't by any means eliminate the human impact and almost a little bit more of the artistic sense of seeing and interpreting, but in the basic ways of delineating out organs and allowing for further analysis and quantification using those programs, it really is quite useful. Mike, let's throw it back to you. What are you thinking about this?
I'll really just echo and agree with what everyone else said. I think many radiologists, even people in Adam and my generation, and we're relatively early on in our careers, we saw AI as something that's scary or intimidating, something that could potentially replace us, as Yang was hinting at. But I think it's become a lot more digestible and accessible for a lot of radiologists now. I think COVID has played a large role in that. And whenever you go to any national conference now, there's always a large section or a large portion of every radiology conference that's dedicated to artificial intelligence. So I think it will be a really foundational, critical tool that's going to help all radiologists kind of navigate the future.
That's fantastic, guys. Do you guys have any closing notes? What are your vision towards the future right now, going in with COVID, with the diagnostic aspects, with the treatment aspects, your experience being there on the front line? We all owe an unbelievable debt of gratitude to you guys. What has it been like? Has it been really tough to be on that level of seeing patients and being, that diagnostic having such a huge hand in their treatment, in their course of treatment?
I will say, though, that thank you for those kind words, but we really do have to thank the real heroes and they're the clinicians and the nurses and every staff that was really seeing the patients during the height of that epidemic. I think we as radiologists were a bit protected at times, and that's fine. We all play a role in this outbreak and in this pandemic, and everyone's important. But personally, I just would thank the people who really paved the way to fight against COVID-19.
Absolutely, yeah. It's an unbelievable thanks goes out to everyone, the essential workers, the non-essential workers, everybody who's stepped up and really put forward all their best efforts and put themselves in honestly in a position of risk in order to benefit the world as a whole. I'd love actually to discuss a little bit something that I ascertained from the Nature Medicine paper was this feeling that maybe the way that the AI software was, that the AI algorithm was able to reconcile and make these diagnoses that were before the time that radiology symptoms were being shown. They had talked about, a 68%, these patients, these 25 patients who had positive RT-PCR, but had not yet shown radiology symptoms. So does that almost suggest that the AI algorithm was working as a concerted, collaborative effort between the different inputs that you have, the clinical data, the test that hasn't yet come out? Obviously, we're talking about, as we were discussing before, these are concurrent tests running, so that changes that workflow a little bit. But does it almost suggest that there's some more communication that needs to happen between team members of a healthcare team?
Maybe I can comment something. So Yes, it looks like you read the paper in a very detailed way. So yes,
you have to. What you guys did was incredible, and it's really cool.
So I want to make some general comments. So the AI or whatever computer algorithm you can imagine, they all based on what kind of you feed them, and then also learn from what you feed them. If you didn't feed them the feature, they might self-learn something, but most of the cases they cannot. So which means that's why for our when we do the research, we are trying to incorporate as much information as possible, for example, imaging, features of a clinical, symptom or clinical information. So the more we feed them, there's always good and pros and cons. The pros is the computer might see more stuff. The cons maybe they see too much stuff and then they don't know which one is the right one. So which means when you design something, you also need to do very careful about sensitivity analysis, etc. stuff. So to extract the key features, whatever, or let the computer to automatic or self-learning to select the key features. But overall, generally speaking, I think the more you feed into the system, the better you supposed to have better results. But which also means the synchronization of all kind of stuff like radiology images, some clinicians, for the clinical information, etc. So I think this is definitely a true teamwork if we really want to move forward for the next step. Integrate all the kind of useful information and then make a comprehensive diagnosis. This needs a really teamwork for that.
Absolutely. It all goes back to teamwork, and here at Sinai and beyond, it sounds like teamwork is something that we have in abundance right now. Teamwork and hope, which is incredible. Yang, as a closing little thing, I really find, and I've personally benefited from it as we were all coming in during this time. And again, I was off the front lines as well, so thank you to those who truly were. But as we were doing COVID research, we were only able to do it in the beginning when supply chains were still really tough with PPE, because you had an incredible collaboration with friends and scientists from China who were able to send and supply huge stocks that we're still using through of PPE. So tell us a little bit about that.
I'm glad that helped, to tell you. So this is also an interesting or funny story. So at the very beginning, it's interesting because we mentioned the outbreak started in China first, and then when we get here, like in March, actually in China, they are way better now. So they have a lot of piles of PPE. And then at that time, U.S. needs a lot of potential, especially our institution, we lack of the PPEs. I just for curiosity, say, hey, do you guys have some spare, storage or whatever? And then they say, okay, we have a very formal way. You can fill out a form, and then we can send you some donations. I said, that's fantastic. And then luckily, I just fill out a form in the name of our institution and ask for anything. I didn't request any amount. I just say, give whatever you think is reasonable for us.
Right.
And then one day I just received because I leave my own contact information to them, my cell phone number and my home address. They were shipped from China directly to my home. And then one day morning I received tons of SMS messages say, you have a DHL package, picked up, whatever. I say, oh, maybe small boxes, and they just, separate into multiple small boxes. And then when they arrive at home, I'm astonished. Each one is a huge size, and then we receive maybe 15 boxes, which is thousands or even 10,000 of masks, and guns or etc. So to tell the truth, I'm very, grateful for them. Appreciate for their very generous donations.
Exactly.
And then it's kind of the whole world fight together. Not only China fight their war and then US fight their pandemic. I think the whole world eventually fighting to join together to fight this pandemic, because you can imagine one country survive doesn't mean a whole world survive, because it's so spread so fast, and then human transmission is very crazy. So only the whole world have battled this completely, it will be gone. Otherwise, it's impossible to totally kill this kind of enemy.
Exactly. So I think that that's kind of the closing overarching theme of this whole discussion and experience, which is collaboration, and not just between humans and humans from very different places, but also between the machines that we make and the tools that we utilize. Thank you guys so much for joining today. Thank you for taking the time. I thought it's been a really interesting discussion, and hopefully people think so as well. Thank you guys very much. Appreciate it.
Thank you, Jazz.
Thank you. Yeah.
Absolutely. Best of luck, and thanks again.